Hi everyone, so we're on day 2 on my website, and if you click on where Bakari is, that's where you'll find this website that I'll be working from. I just wanted to run through this real quick. We have student practice problems. Normally I'd let you do that in class. I hope that you'll attempt some of these and try to practice some of the methods I show you. We have Kahoot factoring problems. Those are problems that we can't do because we're not going to do Kahoot. We would do that if we were in class, and then we have to give notes on solving linear and rational equations, and then practice problems, and more Kahoot. So we're not doing 5 and 6, and we're not doing 2 and 3, but we will do 1 and 4 from this list since we are not in class. So let's look at some different methods, and the first one we're going to look at is factoring by GCF. So if we look at number 1, we have 18x plus 27. GCF means greatest common factor. And what that means is the greatest number that multiplies to each of these numbers, or the greatest number, letter, or variable that goes into everything else. And so what I mean is, we have 18 and 27. Well, 1 goes into both of those. 1 divides 18, 1 divides 27. 3 divides both of those. But 3 is not the greatest. And the reason it's not the greatest is because 9 is the greatest. So if we do 9, then we factor a 9 out, so we do 18x divided by 9, which gives us 2x. And then 27 divided by 9 is 3. And so this is the solution. This is the GCF. And then this is what multiplies back to the GCF to give us the original. Let's try it one more time. Let's do one with 4. Let's do one with x's. 4x squared minus 8x. Well, remember, obviously here 4 goes into both of these, so 4 is the GCF, so 4 will get factored out. Now what do we do with x's? Remember, this is x times x, and this is x. Well, this one, if I tried to pull 2 x's like here, this one doesn't have 2 to give me, so I can't pull 2. So I'm going to pull the 1x. So I'm going to borrow 1x from this one and 1x from this one. And so that's going to leave us with 4x times what gives us x squared? Well, that would be x. And then 4x times what gives us negative 8x, which is negative 2. So just to check it, this is the GCF, obviously. Just to check it, we have 4x times x minus 2. If we remember distribution, multiply this to this, that's 4x squared. Multiply that to that, that's negative 8x. And so since this matches this, we know that is the GCF, and we've done this correctly. Let's look at number 7. I want to do one more because there's some more challenging looking ones. We have x plus 5. 3, oops, I don't need the parenthesis, 3x plus 5. So what do we notice the GCF is here? Well, you see there's an x plus 5 and an x plus 5. Remember, that is just a number if you plug something in for x. And that number will match every time. So we can factor that out. X plus 5 is the GCF. And what's left here is the x. And what's left here is the positive 3. And so this is the GCF, and then this was what was left over. Okay. All right, next we're going to do grouping. So x to the third minus 2x squared minus 5x minus 10. To do grouping, what you're going to do is you're going to cut it in half. So you're going to cut it right in the middle. And then we're going to do what we've been doing with the GCF for the left side, then we're going to do it for the right side, and then we're going to see if they match. So this has 3 x's. This one only has 2. We're always going to take the lower one, so this is x squared. And x squared times what gives me x to the third? That would be x squared times x. And x squared times what gives me negative 2x squared, which would be negative 2. Okay, good. So far, so good. Now, we can factor out here. If we factor out just a 5, we're not going to get... well, let's do it real quick. If I factor out a 5, I have 5, and then 5 times what gives me negative 5x? That'd be negative x, and if I do 5 times what gives me negative 10? That's negative 2. And so that didn't work out very good. Did I copy it down wrong? Let me make sure I didn't. Plus 5. Oh, this is plus 5x. Sorry. Yeah, I did copy this down wrong. Okay, so if I factor out positive 5, then this is positive x. Let me fix this. Okay, so that did work. All right, that's better. Sorry, with the problem that I had written, I would have gotten this to not match, and that would have not worked. And so this one actually works, so I guess I should have just wrote it here. Sorry, I copied it wrong. And now we have a situation that's similar to the last problem we just did, this one here. Notice we have an x minus 2 and an x minus 2. Well, we're going to factor that out, and it leaves us with x squared plus 5. Now, sometimes this will factor as well. That unfortunately does not. Well, maybe not unfortunately for you, because it's more practice, but sometimes that factors, and that would be required to factor, but it not always. So in this case, it does not. The reason I know it doesn't is because if I set this equal to 0, I get an imaginary number, which I'll talk about later in the videos for this day. Okay. Let's do 14. X to the third, 6 squared. All right, so let's do this one. So, still by grouping, we're factoring out an x squared. That leaves us with x plus 6. If you don't see how I did that so quick, just, take some time. Sorry, I'm erasing because I don't like how I wrote the x squared. That's x squared. If you don't see how I did it so quick, make sure you watch the other part of the video right before this, and I think it'll help. And then what I'm going to do is I'm going to factor out a 2 in this case. So if I factor out 2, then I need negative x and negative 6. Why? Because if I FOIL this back, I should get this thing, and I do. But notice that that and that do not match. So I need to factor out that negative. So if I factor out negative 2 instead, then I get x plus 6 here. Once they match entirely, oops, I don't know why I drew the right triangle. Once these two things match entirely, then I can factor them out. So this is x plus 6 and x squared minus 2. And you are done here. This one actually does factor. It would give you a square root of 2 and square root of negative 2, but I'm not going to make you do that. Let's save that for pre-cal. And so that is the end of that. Now let's try x squared plus 5x plus 6. We're going to use a new method for this one. We're going to use what I call the x method. We write what multiplies to this. Okay, so there's a form. It's ax squared plus bx plus c. What goes on top is whatever a coefficient times c is. And then what goes on bottom is whatever b is. Okay, so if I draw the x again, a times c, well, this is a 1. 1 times 6 is 6. That's this times this. And then b is the middle, which is positive 5. I need two numbers that multiply to 6, but add up to 5. Well, that would be 3 times 2. Notice this times this is 6. This plus that is 5. Okay, so if positive 3, positive 2, so this is x plus 3, x plus 2. This is your factoring for this problem up here. Kind of just makes that thing appear. Okay, so I'm going to start erasing some stuff we don't need. We don't need this box. Okay. Sorry, I guess I should make my screen a little bigger so you guys can... Uh-oh, I need to turn off my circle thing. Let me do that real quick. It's not that long. Ink to shape is gone. Okay, here we go. So let's do another one. Let's do 20. Oops, 20. the heck am I doing? Okay. Sorry about that. Let me write this again. 20. So we have x squared minus 4x minus 5. Once again, we want 1 times negative 5, which is negative 5, and then negative 4 multiplies to negative 5, adds up to negative 4. Well, your only chances for 5 are 1 and 5 for multiples. And one of them obviously has to be negative, and it has to add up to negative 4. So if we do a negative 5 plus 1 is negative 4. Negative 5 times 1 is negative 5, and therefore we found the correct answers. So this is x plus 1, x minus 5. Okay, and that's how that is done. The next method I'm going to show you is called the Snowflake method, which you do this when you have a variable in the front, or I'm sorry, a coefficient in the front that is not 1. These are 1 because there's nothing there. This is a 3. So, Snowflake method looks like this instead of the other one. The only difference is in this part right here and this part right here, you're going to write whatever this coefficient is. So we're going to put 3x and 3x. Okay, now, top is still the same, bottom is still the same, so top will be negative 6, bottom will be negative 1. And we look for two things that multiply to negative 6 and add up to negative 1. That's going to be negative 3 and positive 2. Okay, so remember negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. That is an ugly 6. I don't know why I just drew that. That's gross. Okay, that's better. Okay, now we look at these two things. And we're going to simplify them like fractions. So what I mean is this is a 3 and this is a 3. That's a 1 and a 1. And then this one, 3 and a 2 do not simplify. So this is going to be 1x minus 1 and 3x plus 2. And that is your factored version. If you multiply this back, we'll do that once or twice. I'll do it after I do the next one, I'll do it. And then we'll do difference of squares. And then we will have to do polynomials of types 3. So let's do one more of these ones. We have, actually I'll make a new video for those ones. So we have 26, 3x squared minus 2x minus 5. This is not 1, so let's do Snowflake method. So 3x, 3 times negative 5 is negative 15, and negative 2 multiplies to negative 15, adds up to negative 2. That's going to be negative 5 and 3. This one does not simplify. This one does. 1 and 1. Notice this is positive, so positive 1. So this is 3x minus 5 and x plus 1. If you want to check your work, this times this is 3x squared. This times 1 is positive 3x. This times that is negative 5x. That times that is negative 5. This is 3x squared. These two combine to give us negative 2x minus 5. And since that matches this, we are good to go. That is called foiling. You can watch a video on that. if you need to. Alright guys, I'm going to end this video here. We're going to do a couple more types of factoring and I'll make new videos for this, so keep watching the playlist and then we'll get moving on to the rest of the stuff for this day.